Good morning, all. Today we are going to see the theorem, name is Reciprocity Theorem. So, in this theorem, we have to consider a single source only. That is the conditions. This is one of the condition, and the network should be linear and bilateral. So then only you have to proceed the reciprocity theorem. So before enter into the reciprocity theorem, we have to recall what are the topics we are discussed in the last class. That is, for last class we have seen about maximum power transfer theorem. So maximum power transfer theorem is one of the theorem which is consists of maximum power transfer, which consists of RTH is equal to RL. And how can we decide the RL is equal to RTH? That proof we have discussed, and along with this simple problem we are discussed. So now we are going to discuss reciprocity theorem. So reciprocity theorem consists of, before that, what are the topics we are going to see? Statement and linear and bilateral networks for condition, and response of the sources and limitations also we have to see in this session. So reciprocity theorem is in a bilateral network, linear bilateral network. If a voltage source Vn is the branch of A produces the I, and the same source you have to change into the B branch and find the current for the branch A. So both currents are same. For that we have to find the resistance value of the hole. So this is what we have to consider the reciprocity theorem. So once again I repeat, that is, if there are two branches are there, so first we have to consider the voltage sources available in the branch A, then we have to find the current of B, branch B. Then the same source we have to replace into the session of the branch B and find the current of session B. But both currents are same. So this is the reciprocity theorem. So let's see the example. So here we have to consider 36 volts in B branch and find the current, and the same we have to change into the ECA branch and find the current for the B. So this is the diagram for considering the example. That is the 36 volt voltage sources available in the branch A session. So first we have to find the resistance equivalent, that is total resistance. So the resistance 3 plus 1 are in series. So we have to add these two, and the 4 amps is parallel with the 12 amps, and the resultant will be series with the 2 amps. So here I have to write like this: 2 plus 12 parallel with the 3 plus 1. So finally you get 9 amps. That is 9 ohms. So now we have to find the current. It is opposite resistance divided by total resistance into total current. So I have this we have seen the value of 4 amps we have to find out. So based on this we are find the value of current. And for the next session we are changing the source into B part and find the A value. So in that 3 is parallel, that is 12 is parallel with 6 ohm, and the combination of this result will be series in 3 and 1. So finally we will get 8 ohm. So 8 ohm is get amp is voltage by resistance. We know that this voltage source is 36 divided by 8, and we get 4.5 amps. So total current we will find the session B and find the current of session A. So 4.5 into opposite resistance divided by total resistance 12 plus 6. So finally we will get 3 amps. So we have proved that for the session A also will get 3 amps, for the session B also will get 3 amps. So finally we have to find the transfer resistance, that is T transfer V by I 36 divided by 3 amps. Then finally we'll get the answer of 12 ohms. This is how we are find the value for reciprocity theorem for session A and then session B. And the maximum, this is the define and the empathy of the part. And the real world applications are we are using in the network analysis, verification of circuit results, and antenna and the signal systems. And here I have given a few references. So check it out, and if you have any queries, you have to ask. See you in the next lecture. Thank you.